I listened to a lot of roots reggae when I was in my early 20s. Being a stoner in school generally meant that there was a lot of reggae around. But in my early 20s, I discovered the band Israel Vibration specifically, and everything changed. There are many other bands in the roots reggae genre, but for me, Israel Vibes is the quintessential roots band. For me, anyway. Israel Vibration embodies the essence of roots reggae through their messages of spirituality, social consciousness, and liberation. Their use of rich melodies, uplifting chord progressions, and melodic horn arrangements further contribute to their quintessential roots reggae sound. They address themes such as African identity, Babylonian system criticism, the struggle of the oppressed, and the importance of faith and perseverance. Israel Vibration's lyrics resonate with the poetic nature of roots reggae, encapsulating the struggles and hopes of the Jamaican people. Surely, I listened to lots of the popular reggae at the time, and these themes imbue most reggae. But I didn't understand the authentic roots and meaning of reggae in my soul until I listened to Israel Vibrations. Similarly, we can talk about the importance of cannabis roots, a thriving rhizosphere and root zone, and the love of a thick mass of healthy plant roots. But only when we really lean into roots culture, cannabis roots science, will we have both the heart and the knowledge to grow our best cannabis plants ever. If you want to learn about cannabis health, cultivation, and technique efficiently and with good cheer, I encourage you to subscribe to our newsletter. We'll send you new podcast episodes as they come out, delivered right to your inbox, along with commentary on a couple of the most important news items from the week and videos too. Don't rely on social media to let you know when a new episode is published. Sign up for the updates to make sure you don't miss an episode. Also, we're giving away very cool prizes to folks who are signed up to receive the newsletter. There's nothing else you need to do to win except receive that newsletter. So go to shapingfire.com to sign up for the newsletter this week and be entered into this month's and all future newsletter prize drawings. You are listening to Shaping Fire, and I'm your host, Shango Los. My guest today is plant biologist Sarah Lane. Sarah Lane is wrapping up her PhD in plant and cellular biology at University of Victoria. Her work primarily focuses on root exudates that are involved in iron uptake in plants and their potential medical benefits. Sarah consults for licensed cannabis cultivators in Canada and is an avid living soil cannabis homegrower. Due to her university research needs, she is also very experienced in fogponics and hydroponics. Sarah has a wicked large plant collection and is currently designing a specialty terrarium for growing cloud orchids. Sarah Lane appeared on Shaping Fire 99 just a few episodes back, talking about the symbiotic relationship between roots and other residents in the root zone via exudates. During the first set today, we will look at how roots and root hairs are created, how they absorb nutrients, the exudate relationship, and how different fertilizers impact the root zone. The second set is devoted to root structure. We will look at the various forms of root structure in soil, coco, and hydroponic systems and why they work and don't work. We will look at the relationship between root structure and the soil food web. And we will discuss how various growing containers impact root structure and what that means for your plant. And finally, we will finish off with a discussion of best practices for growing a healthy and thriving root structure, including water, pH, soil amendments, and cover crops. Welcome back to Shaping Fire, Sarah.
Thanks for having me. I'm happy to be back.
So glad to have you. You know, I don't usually ask guests back right away, but our discussion of root exudates during episode 99 just brought up so many root-related questions for myself and then in the comments online that I just knew that it was probably better to just invite you back right away and push forward into our discussion of roots and root structure. So thanks for making the time to come back right away.
I'm so excited.
So let's dive right into it. And we're going to start out with some basics because it's become pretty obvious over the years of taking questions from audience members and you know the people who I talk with at conventions that there's a lot of us in cannabis cultivation that kind of take roots for granted. And so we're going to start with some basics of what are roots and how they form. So let's start with the ultra basic. What are roots made of and how are they formed by the plant?
Oh, goodness. So roots are basically an organ of the plant that are made up of a couple of different types of tissue There's vascular tissue to help transport water up into and nutrients up into the rest of the plant. It's surrounded by some other tissues that can kind of respond to the environment. There's an epidermis layer that kind of acts like a skin around the whole thing to prevent like microbes and things like that from getting in. And the purpose of a root is basically to provide anchorage so that the plant stays put and can survive wind and all that kind of stuff. But it's also for getting nutrients into the plant.
Mm-hmm. My understanding is that there are different types of roots. There's like the primary roots, the big chunky parts that we can see, but then they seem to have like smaller and smaller branching roots all the way down to the root hairs. How many different flavors of roots are there?
Oh, so many flavors. It also depends on the type of species. So very broadly, the type of root system that you can have depends on what species you are. And like I think for most angiosperms, so those are the flowering plants, they get split up into like roots that can form from a taproot and then roots that are fibrous. And a taproot basically just means that the plant will make one big long root that goes down and lots of roots will come off of that. A fibrous root system is kind of like it's closer to the stem and they're not as long, they're kind of just lots and lots. But there's also many other plants that don't even have a true root system that have like kind of root-like structures. And then when we get into just like a regular root ball that we're familiar with, so like a houseplant root ball, for example, there's the primary root, but these can get split up into other like branching lateral roots that kind of move away from the root into other parts of the soil. And then from there, you can have, I guess root hairs would be the next option. It's just like a single-celled little root hair that sits at just a very short amount of distance from the root itself, and that helps kind of pull up some more nutrients in the area.
So let's talk about that taproot for a moment. Since we are talking about the roots specifically for our favorite cannabis plant, it comes up all the time. People will say this just kind of off the cuff. They will say, they prefer to grow from seed because they want to grow a plant with a taproot. Because when we clone cannabis plants, the clones, when we plant them, don't have tap roots. Is there a particular reason why clones don't have tap roots? And what is the function of the tap root in a seed plant that we are missing out on when we grow a clone?
Ooh, that's a really interesting question. So I guess when we talk about the types of root systems that a plant can have, we are usually referring to like a developmental thing. So the plant, when it's in a seed, is programmed to have a taproot root system. When we clone, we're actually taking advantage of almost a wound healing response instead. So the plant has the ability to make cells that wouldn't normally be roots turn into roots to help it survive, but that isn't necessarily how it was developmentally designed to do. So when we go to the taproot, when you grow from a seed, that taproot goes as far down as possible to get as deep as possible into the earth. And the advantage to like having a very long taproot is that if you can go like meters and meters down into the soil and then produce lateral roots from there, then you can access so much more of the ground to get your nutrients from. And if you have like a really short taproot, then you're probably like, if you can only go 4 inches down, you're only able to access that much of the soil. And so when you grow from a clone, I don't think it truly matters in the long run because we're usually growing in pots, and pots, like even if you have a taproot system, you can only get to the bottom of the pot and then you're going to be branching out from there. But from a clone's perspective, like you wouldn't have, if you were growing out in like, I don't know, a field, you wouldn't have access to that same depth of nutrients. It would be harder for you to get to.
That makes sense. I'm going to push on this one more question. I love the perspective that you shared about how a clone rooting itself is kind of like a recovery or a first aid event because it's been damaged and it's repurposing other, dare I say, stem cells, different cells in the plant to create this root environment. Does the plant get stabilized and kind of shake off that damaged first aid kind of living bias and like become a thriving plant, or will a clone forever be hobbled by the fact that it wasn't from seed?
Oh, I love both. There's two things I want to talk about now. So absolutely, plants can recover quite well. And if you think about it, they have to. They don't have feet like we do. They can't just like wander over. So a lot of their like responses, they're constantly adapting to a new environment. And if it was one damage event, like say they got flooded or something, and then they can't recover, they wouldn't survive very well. So like any wound or anything like that you can do, usually as long as you treat it properly and it comes back to a healthy environment, you should be totally able to recover, which is often why many different types of plants are vegetatively propagated, including like potatoes and all sorts of other plants. But the idea of a stem cell, plants do actually have the ability for so many of their cells to become stem cells. Oh. Unlike us, where we just have this little tiny amount of stem cells when we're born, and there's a couple of pockets of stem cells in our body that can react in certain ways. Plants, almost any cell can become a stem cell that will then be able to be any other part of the plant. That's why tissue culture works so brilliantly.
Right on. I'm glad that I stumbled into that brilliance. I didn't realize that was the case. I was trying to make a pun. So good. Thank you.
No, it's perfect. This is a stem cell, but it's also a stem cell.
Right on. So let's talk a little bit about the roots' job of bringing in nutrients. So one of the things that we talked about in the Exudate show that I found so interesting is all of the different ways that roots mechanize bringing in nutrition in different ways. And, on Shaping Fire, we tend to focus on living soil solutions, but we'll definitely be covering, all other types of substrate today, especially since we're talking about roots. But for this question, what are the forms of various nutrients that roots can absorb, assuming that they are in thriving living soil environment? Because I'm assuming that they're gonna absorb like minerals in one certain way and maybe fungus in a different way. And I think you understand what I'm asking. Mm-hmm.
Okay, so if I understand what you're asking correctly, how do roots take on different types of nutrients in the soil?
Yes.
Is that right?
Mm-hmm.
So there's a bunch of different things. When we're talking about, I guess, all nutrients at the end of the day can be broken down into nitrogen or phosphorus ions or like basically a salt. And that happens either because the plant is able to provide some sort of chemical or enzymatic process that can break something down right next to it, or because some bacteria or fungus next to it was able to do the same thing and they can take it up that way. There is some evidence that plants can take up nutrients as slightly larger molecules, but I think this is very species dependent. I don't think all plants can do this, or at least I'm not familiar with enough papers that have shown this to be kind of a universal thing. And then when it comes to like bacteria or mycorrhizae or those kind of things, it's more of a conversation between the organism and the plant. And that involves some chemical signaling and some invitations are sent, and then the plant is able to repurpose the structure of the root to house it. So it's not necessarily that it's actually getting into the cell, more like it's getting a special place in the root to grow. Mm-hmm,
mm-hmm. Your answer seems to suggest that, another good reason that if we're going to be growing in soil, it really behooves us to try to make a thriving and varied, living root zone, because if the roots themselves are not necessarily breaking these different nutritions down, and it's their partnership with bacteria and other types of microbes, all those friends need to be there. And the ways that, all the ways that we try to create a thriving root zone and not drown them with our water is all important if the root zone is going to be able to have the buffet that we want them to have in their living soil.
I would agree, yeah, for sure. And the more vibrant that community is, the better nutrition is available. And not only that, a lot of the microbes that are found in the soil provide other benefits aside from nutrition, like competition against pathogens, for example. If you have a lot of healthy bacteria down there, then there's less room for an unhealthy bacteria to show up. It might just be stimulating the plant to make little immune compounds because they're there and they don't react strongly to that particular fungus, but they're aware a fungus is there and they might be more ready. There's so many things that they provide.
I know that you do a lot of aeroponics, and so this may be an unfair question to ask you specifically for living soil. And I'm not looking for us to like plug any manufacturers, but as somebody who is constantly looking at ways to create healthier and more thriving roots, as you do in your research, are there any inoculants or particular teas or anything that you would recommend for living soil people to help support this thriving rhizosphere?
Yeah, I mean, so for my research, I'm generally trying to avoid the presence of bacteria as best as possible because I'm really trying to just get at the root. But I do use compost teas a lot when I'm growing at home. And I usually, I don't know, in places where you can get them, there's like a nettle, horsetail, brackenfern tea that you can use. A lot of them have molasses bases, which is really helpful to get certain types of bacteria and fungus to get growing. There's like so many good recipes online. It'd be hard to plug just one, but if you go and have a look at some compost tea recipes, I think the simplest ones are the best. Like a little bit of soil that's healthy, plus some sugar sources, plus some plants is usually a good start.
Plus, in the one that you mentioned, I mean, you've got the silica from the horsetail and the growth hormones from the spring nettles. I mean, that's a pretty potent mix you just suggested too.
Oh, it is.
Yeah.
Yeah. I guess the other one I would say too is it depends on the stage that you're adding it. Because I will often, when I have very young plants, I'll do like a barley tea. So you soak barley for a little while, and all the different growth factors that allow the barley to sprout are then present in the liquid. So you can either buzz it up or you can take the liquid off and put it on young seedlings. And it's thought to help grow, and I do it myself.
Right on. Good clue. So when you were back recently, when you were here the first time recently on episode 99, that show was all about exudates, which is a process that the roots bring on nutrients. Now, granted, that's an hour and a half episode that we talked about exudates, and I'm going to ask you to summarize it just in a short answer. And because I think it's important that folks understand that roots do have this exudate relationship because it's pretty badass. But I'll my goal is maybe hopefully to tease people with this so that they understand kind of what you're talking about for this episode, but then to encourage them to go back and listen to episode 99. So will you just briefly explain how cannabis roots work with the exudate relationship?
Yeah. So broadly speaking, exudates are molecules that the plant root will make that goes outside of the root. And it's made inside the root, it's exported outside the root, and while it's out there, it can do lots of different jobs. It can provide food for microbial communities. It can help to loosen up some nutrients, like we were just talking about, break down nutrients and things like that nearby. It can provide some protective efforts too to prevent, I don't know, like it could be antimicrobial or antifungicidal or something like that. And they're just a huge, broad range of molecules that do this job.
Excellent. So go back and listen to episode 99 for more. So I'm really curious. We've already talked about how the roots take on nutrition. And I believe that mostly happens at the root hair level. Would you explain to us, in kind of both a chemical and a mechanical way, what's actually happening there at the root hair that allows the nutrition to come on board inside of the root?
Sure. I mean, I think for the root hair, it still kind of comes across the way that it would come across in a lot of other cells. So when we're talking about transport from outside in the soil environment into the root, all cells are wrapped up in this nice little membrane that has, essentially you can think of them as like little trap doors for nutrients to come into the root that are regulated. So you'd have to turn on a switch for them to come in. And that happens, all cells are doing this all the time, and that is no different in a root hair cell. The big advantage to root hairs is its increasing absorption. So if you think of how big a root is and how visible it is, you could see it. It's usually, depending on how long the plant's been growing, it can be super thick. Whereas these root hairs are super, super tiny. And so while the main root can plow through the soil at a pretty good clip, the little root hairs are meant to kind of slide in between soil particles and increase the surface area. Does that make sense?
Yeah, it does.
So that's kind of their primary purpose, is to increase the absorption rate. And when plants are trying to choose what kind of doors they want on their cells, the root hairs will often have a lot of, like for my work, I'm interested in how iron gets in, and those root hairs can have more iron doors on them so that more iron can get in on those root hairs than they might in a regular cell.
I like that trapdoor analogy. And so there's all these different flavors, and they only open when they are looking for the particular nutrient that approaches it.
Exactly.
Like there's a secret knock or something.
There is, yeah. A little handshake.
So, cannabis cultivators often come into contact with the roots, right? Like sometimes just briefly when transplanting, but other times if the plant is root bound in a container, we might be really aggressive with the roots, like grabbing them and ripping them and thinking that we're getting rid of tired roots that were compacted. And most people will say, oh, I'm stimulating new growth by pulling these roots that were compacted off and giving it more room to breathe. How careful should we be when handling the roots? Because on one hand, because I learned it from my mentor, the ripping apart of the roots makes sense because that's what I was taught. But I also constantly hear from soil biologists that the roots are very sensitive and we can put the plant into shock. So I'm assuming that the truth of the matter is somewhere in that range.
I would agree, actually. So I don't think it's wrong to think that you are stimulating growth, because just like we were talking about earlier with the clone and how that's a wound healing response, that it makes more roots. When you damage the roots, that is definitely something a plant will respond to, and it will make more. So it's more about hoping you don't damage it so much that the plant is overwhelmed. I think roots are very sensitive. So as soon as you take them out of the pot, they're being exposed to light they weren't expecting. You're touching them. A lot of those finer structures, like the root hairs, that are so small and fragile, they're only a single cell thick. So you're definitely destroying those, and it will definitely take the plant some time to recover from that. I think it depends on the type of plant that you're working with.
Well, so specifically cannabis.
Yeah, but there's going to be a certain amount of cannabis plants that are very sturdy, but there might also be more sensitive plants that maybe don't grow as well.
Oh, I get you mean specific, what we call strains or varieties, not different species entirely.
Yeah, I mean, I grow a lot of plants, so I would say species too. But if we're talking strictly about cannabis, different cultivars are definitely going to have different vigor. Mm-hmm, and so in a plant that has a lot of vigor, you're probably okay to maybe manhandle the pot a little bit more. But in a plant that's very sensitive and doesn't grow that well, it's going to be trickier. And I think most of the time I would say that unless the roots are dead or diseased, I would try and keep them intact as much as possible. You can break them up a little bit, like when you encounter, particularly with hard-walled pots, sometimes you see the roots kind of run around in a big circle. Yeah. And so you can kind of try and loosen them up so that they'll not break them, but try and kind of untangle them a little bit so they might go somewhere else.
Fluff them a little bit.
Yeah, exactly. So that would be okay. I mean, I try and be as gentle as possible with my root balls, but yeah, it's going to happen regardless. I think just the extent that it happens, you might have to be careful with some cultivars over others.
Would it be fair to say that if we're growing from seed and we have a taproot, we definitely shouldn't mess with that? Just, if we're gonna trim roots, secondary roots, don't be touching the taproot?
Yeah, I think that's probably fair. I don't know enough about what happens if the taproot gets super damaged, whether it would produce a new taproot and how that developmentally would occur. But I think it because it does serve this different function than the other roots, that if you damage it too much, it will cause changes. And I don't know whether those changes would be good or bad.
And I think it would be fair to intuit that, a damage to a taproot would put, extra undue stress on the plant that it would have to bounce back from. And since we're all dealing with a timed growing cycle, that none of us want to cause that slowdown in growth. So for our plant, we should probably just stay away from it.
Yeah, and I think this actually is a good point that you're bringing up, the whole timed thing. if you have like a mother plant that's meant to be in vegetative growth for a very long time, and it'll never get flipped over into flower, you might have different choices to make. So, for example, it gets root bound because it's growing so long, and maybe you don't have a bigger pot, so you kind of have to do some pruning above and then some pruning below. And like those are choices you would have to make with a mother plant, and how much or how little you do of it would probably, again, depend on the cultivar. When we're dealing with like a plant that's about to go into flower and it's only got a certain amount of time, that's where you really don't want to damage the roots too much, because they don't have enough time, and all the time that it's going to spend recovering is time that's not necessarily going to be put towards yield. So in a yield situation, absolutely, you definitely don't want to be, making that plant suffer too much.
Awesome. That's a great delineation. Thank you. So what biology determines if the roots, you know how like when you go to transplant, when you pull it out of the pot, sometimes it's got those like bright white, like pearly white teeth, beautiful roots. And then sometimes it'll be like, somewhere between a little more beige or gray. And then you've got roots that are just like, sad. Is it just our guesstimate that the white roots are the most thriving? Is that the ideal? Or are lots of different roots of different colors perhaps just different kinds of roots? Because when I see the bright white roots, I'm all like, hell yeah, I'm doing good. And when I see the beige ones, I'm like, oh, I'm not, treating this pot right in some way. But like, I really don't know. I just made that up.
Oh, what an interesting question. Okay, so the root, like all of the root is important. I totally agree. I love seeing those little white root tips. And in aeroponics, sometimes they're a little fuzzy because of those little hairs.
Oh, that's
the
so
hairs
cute. Yeah.
They're adorable. And they only occur usually pretty close to the root tip because then they die off, and then the plant has other, like that's where you might see a lateral root form or something past there. So the white tips are the actively growing parts of the root, which I think is why we love them so much. And we're like, yay, we've got a lot of white growing areas. But the rest of the root's still super important. And the browning isn't necessarily because of bad things. So oftentimes what will happen is different chemistry happens at the tip of the root compared to the older root. Plants might put down, for example, more tannins or protective molecules that will change the color of the root, but that's because the function of the older root is different, if that kind of makes some sense to you. It
does. Mm-hmm.
Yeah, so when we see those kind of browner roots at the closer to the stem, that's just because the function has started shifting, and so the chemistry of the root has started shifting. And like it would be hard to pinpoint exactly what is happening there for a given cultivar, but that's generally what's happening. The ones where it's scary is when there is a black root tip, I guess. Like if that black or dark brown or those kind of colors are happening at the very tip of the root, particularly in cannabis because its root tips are white. I do work with some plants that have a whole bunch of different colors happen there. But in cannabis specifically, the white tip, if that's starting to brown or anything like that, you might have a bacterial problem. So yeah, it just depends on where it's happening, I guess.
Mm-hmm. So let's say not quite as bad as that black tipped pathogen version, which sounds like a horror movie to me.
It
Is
is.
there any way for us to identify roots during transplanting that we should shave off? Because, historically I would shave off a bunch of those beige ones if I saw them. And now I know that that was probably not well thought, because perhaps the plant is creating tannins in those regions for, safety and security reasons. And I just cut them off. Is there any way for us to recognize roots that are a damaged part of the system that should be shaved off?
I think you can kind of think about it. I guess the other part is there's a connection between the roots and the shoots where there's usually certain roots that service particular parts of the plant above. So it's really hard for us, looking in the pot as we're trying to transplant, to be able to determine oh, this branch I cut off here are these roots here, so these ones can go. So I think it is a bit of guesswork. But if they're particularly dry looking, they're kind of shriveled, and when a root is full of water, they're kind of, I don't know what the best word to describe it would be, but they're almost plump, they have kind of a juicy look. And if they're unhealthy or dead, oftentimes they'll be quite thin, like a thread almost. And so maybe like the thready ones you can get rid of a little bit more easily. But it is a lot of it's guesswork, and I don't have a firm answer for you as to which part would be. I usually, for myself, I look for, as we were just talking about, kind of like the browner root tips that might be experiencing some bacterial effects or something like that. But there can be good bacterial effects too. So I generally just try and do my best guess.
Right on.
I wish I had a better answer.
Well, no, that actually is pretty good, because what I took from it is that if you see roots that are particularly emaciated and they visually look thin and like they're not carrying water, that perhaps those can be removed. But generally speaking, we want everything in the root zone if we don't see like a black or colorful tip on it. So just give your roots a light fluff and then go into the bigger pot, and just don't think you have to touch the roots when you're transplanting. Don't assume that that's going to be part of your transplanting process. Only do it if you actually see visual problems.
I think that's a pretty fair statement. Yeah, or at least that's what I do. And I know lots of people have different philosophies on what the best solution is, but I think for getting your plants to recover quickly from transplant, like as little damage as possible. And as you say, like if they look emaciated and they're really sad looking roots, like maybe trim those off. But otherwise, a little fluff will do you.
Right on. One of the interesting, you said, everybody's got their own philosophy, and that's true. And there are different ways to have different philosophies within actual science. But I think when it comes to cannabis, we've all been taught so much like bro science by our mentors and then from friends that, like if anybody should be decreasing the number of justifiable philosophies, it's our community, because we have so much bad information to root out of our community first. And then once all that bad information is gone, then people can like find different parts of that the remaining area to, count as their particular technique or philosophy. But I don't know. I kind of think that we haven't had access to proper scientists, analytics, and research folks for the last 40 years. That us all trying to kind of bring the techniques all towards the center, which has actually got a scientific basis, is probably a pretty good set for all of us.
Oh, I agree, and I think that there's all these little habits that we do that we don't really question, and those I like to question myself.
Yeah, me too. Uh-huh.
And as you say, there's a lot of myths and legends about exactly what type of thing you should do at what time and things like that. So I think there's a lot of tried and true methods that have worked for people for a long time. But I do agree that bringing things around to like a scientific perspective and not just doing it because someone told you to do it, which is kind of ironic, me giving advice about this, but, like think about it,
Yeah. So I've got two more questions before we go to the break. Now, in the third set, we're going to be talking a lot about, the care and feeding of a thriving root structure so that we can have the best one available. But before we go to the set break, I want to talk about things that degrade root growth, and two different categories specifically. Are there particular amendments, inputs, or fertilizers that can degrade root growth that we should avoid in cannabis plants?
Oh, interesting. I think this is a more of a conversation of amount, or like what the state is, because this can happen when you're building a soil, but it can also happen when you're feeding fertilizer. Like if it's too, I guess, quote unquote, hot is the term that we end up throwing around a little bit. That can be a problem. And most of the time, I would argue it's because, particularly with fertilizers, it's probably because of pH or something like that, where it's like the poor little root is getting flooded. And I think it also happens more with certain limiting nutrients like nitrogen, where the plant is less able to close the trap door. For example, nitrogen is almost always like all the trap doors are open all the time because there's not enough of it. So if you flood your root system with too much nitrogen, it builds up, but the way that plants convert what we feed them to a usable form of nitrogen to them, all the intermediates between fertilizer and usable nitrogen are toxic. So they'll start killing the cells off if there's too much of it. And I think with soil, if it's not well mixed, it can actually heat up in not just hot as in like too much nutrients, but as in like temperature hot. And obviously, if your root zone is like 60, 70, 80 degrees, you're going to have a hard time surviving in those kind of conditions too. So
I like your example about if we have too much fertilizer in a particular place, that it kind of jams the trap doors open and kind of force feeds the plant to its detriment. That's the same description that people use when describing, bottled salt nutrients, about how it force feeds the plant. Is that what's happening, like at the root level? Is that the synthetically prepared fertilizer is essentially breaking down the doors and going into the roots more nutrition than the root zone would normally let in?
Yeah, so especially I think it's more dangerous with like synthetic or bottled fertilizers because it's so concentrated, and it's in such an available form. The plant doesn't have to do any work, so it just does flood into the root system. And as I was just mentioning, it's not so much that the nitrogen itself is toxic, it's that in order to be able to turn it into something usable, it goes through a toxic stage. So then the roots it's just too much. They can't do that process quick enough to avoid all the toxic effects of that process. It actually can happen with really rich composts too. It just, I think, at least in my personal opinion, it's harder to do because a lot of those composts still need some breaking down, so it's a little bit slower. But if you dump like pure compost at the root zone of a particularly sensitive plant that isn't capable of taking it all up, it'll start to do similar things.
Yeah, right on. Okay, and then the last one is, how about pesticides? Because, sure, we apply the pesticides usually foliar up top, but we know that through, watering and then just the regular biology of the plants, either the pesticides will drip down to the soil or the plant will take it in and move those chemicals, whether or not they be synthetic or, organic, they're going to move them around the plant. Are there any pesticides that we would want to avoid because they too degrade root growth?
I mean, I have a personal bias against this because I don't generally like to use pesticides. Mm-hmm. I think that when you apply, I guess it depends very much on the type of pesticide you're referring to, because a lot of them have toxic effects if they're in too high of a quantity, and it actually can be both the naturally sourced ones and also the synthetically prepared ones. Like if you put too much mint oil on your plants and turn the lights on, like those poor little guys are fried. But with the pesticides, they're still able to take some up through the foliar system, but depending on what mechanism the pesticide is supposed to work by, I don't know if it would degrade the root particularly, but it might have the ability to affect the growth. Like if it's acting like a growth regulator or it's got a heavy metal component to it or something like that, I'm sure that it can be taken up by the plant. And if it doesn't have a way to deal with it and it's toxic in higher quantities, that will probably happen in the plant just like it would in any other system.
It's interesting. We keep on coming back to balance, It's like, mm-hmm. It's like, hey, you've got a lot of different options for how to cultivate your plant, but whichever one you do it properly and not so much that you knock your root system out of balance.
Yeah, for sure. And I think particularly with pesticides, I don't know if I would be I'm not personally aware of any pesticide that if you watered it in at the amounts that you would spray it, it would cause a huge amount of damage. I think if you did that, you'd probably be killing it above as well. But it might affect the root community too. Like if you're adding an antimicrobial or an antifungal agent to the top and then it drips into the roots, I think you'd be affecting the root community more than you'd be affecting the plant. Yeah. Which, of course, does affect the plant eventually. Yeah,
for sure. I have to be careful of that myself because one of my favorite I think of it as a pesticide, but really it's more about discouraging pests. I really like a garlic fermented plant juice on the sprayed foliar during veg because aphids is my big problem where I live. They just don't want to live there. They don't like the experience for whatever smell, taste reason. And so, but if I put too much of that onto the plant and it soaks down into the substrate. Well, garlic also has antimicrobial aspects of it, and I don't want that happening in the root zone.
Absolutely. Yeah. I think it, as you say, it's about a balance. So if you just have to be careful, especially when you're trying to alter something that's happening to the plant in a way that doesn't affect the plant too, it just gets, I don't know. It's sometimes it's subtle.
Yeah, this is well. The more we get into the cultivation specifics, it is more and more subtle, right? It's like when you first start growing cannabis, it's like, oh, just put the seed in the ground and it grows, and then at the end you got some weed, but then you like want more yield and better weed and healthier plants, and you want to keep more plants, and that's where the subtleties come as we get more and more in love with this way to express ourselves. So, right on. So let's go ahead and take our first short break and be right back. You are listening to Shaping Fire, and my guest today is plant biologist Sarah Lane. And, without these advertisers, Shaping Fire would not happen. So please support them and let them know you heard about them on Shaping Fire. As cannabis regulations become more demanding and consumers become more educated, it is increasingly important to avoid the use of chemical pesticides when cultivating cannabis. Beneficial insects have been used for decades by the greenhouse vegetable and ornamental plant industry, and today many cannabis cultivators are moving from sprays and chemicals to beneficial insects. Copert has the beneficial insects, mites and nematodes, microbials, sticky cards, and air distribution units you need to partner with nature to defend your garden. Whether you manage acres of canopy or have a simple grow tent in your home, Copert is ready to help answer your questions and help you transition away from chemical sprays towards clean and natural solutions. Since 1967, Copert has assisted growers in identifying pests and devising reliable solutions while providing healthy insects and mites that will protect your yield. Since the 1990s, Copert has been a leader in cannabis pest and disease control worldwide and have highly trained consultants to assist you in Canada and the United States from coast to coast. With their global network of grower support, Copert can help. Visit Copert.com, choose your country, and get detailed information. That's Copert, Koppert.com. For the most up-to-date cannabis-related biological control information, you can also check their Instagram at Copert Canada. Getting away from pesticides is good for health and good for business, and Copert is ready to help. Visit Koppert.com today. There are so many seed banks nowadays that you really have options in who to choose. Not only that, if you pick the wrong seed bank, you could be in for a really sketchy ride. And that's only one of the reasons I recommend Gas Lamp Seeds to my friends and listeners who are looking for a seed bank. You probably already know Gas Lamp Seeds as Hembra Genetics. Hembra recently changed their name to Gas Lamp Seeds. Gas Lamp Seeds is not just another seed bank. Gas Lamp is a female-operated boutique cannabis genetics provider that only sells thoughtfully curated seeds from the top names in cannabis breeding. With over 60 breeders and over 1,000 strains to choose from, you will certainly find something you'll love. Gas Lamp Seeds has something for everyone, with over 650 feminized strains, 300 regular varieties, and over 200 autoflowers to choose from. Names you can trust, like Compound Genetics, Humboldt Seed Company, Night Owl, In-House, Fast Buds, Gnome Automatics, and Ethos. And we both know that there are other seed banks who will take your money but have no customer service. I invited Gas Lamp to advertise on Shaping Fire after hearing so many good stories about them from my friends. They have A+ customer service with lightning fast response times. In most cases, Helene and Caitlin will get your order out the same day you place it. Most seed banks are simply not this organized or interested in getting your seeds to you so fast. But Gas Lamp Seeds cares. You even get free seeds with every order. Helene and Caitlin get it. They have been in the cannabis growing scene for over a decade. Want some extra freebies? Use the code SHAPINGFIRE, all one word, at checkout, and they will give you an additional set of Gas Lamp provided freebies. That's an extra $30 in free seeds. Buy seeds from good folks who will send you great seeds reliably every time. Visit gaslampseeds.com today. That's Gaslamp Seeds. You've heard me talk about the award-winning cannabis seeds that come from the analytical breeding program of Seth and Eric Crawford, who founded Oregon CBD Seeds. In fact, Seth was a guest on Shaping Fire in 2020 to talk about triploid genetics. Seth and Eric are now releasing high THC seeds for home growers and farms as Grow the Revolution Seeds at gtrseeds.com. Their high THC seeds are extraordinary in that they will start to flower at 16 and a half hours of daylight instead of the typical 14 and a half hours of daylight. That means in most regions, your plants will start to flower outdoors in the middle of July instead of the middle of August, which means these photoperiod plants finish in September and not October, totally upending the photoperiod seed market. Seth and Eric took their prized early flowering CBG line and bred it to some of the most desired verified genetics out there, including Sour Diesel, Triangle Kush, Wedding Cake, Chem Dogs, Skittles, and others. These crosses all express powerful photoperiod terpene profiles and THC, giving you a great high. GTR Seeds has a new THCV line with plants like Double Durban and Gigantor that boast 1-to-1 THC to THCV, and people want that THCV. GTR seeds are very consistent, true-growing, inbred F1s from stabilized inbred parent lines. These seeds are nearly homogeneous, and the plants should all grow the same. There is only one phenotype in every pack, available as diploids and triploids. Seth and Eric's company is still family-owned, patient and employee-centric, and partially powered by their 2 acres of solar panels. Everyone can purchase these seeds and the entire catalog of Oregon CBD seeds at gtrseeds.com. Go to gtrseeds.com today and choose something revolutionary for your next indoor or outdoor run. Welcome back. You are listening to Shaping Fire. I am your host, Shango Los, and my guest today is plant biologist Sarah Lane. So during the first set, we looked at what exactly a root is and the jobs that it does, and some things we want to avoid if we want a thriving, root zone. Here in the second set, we're going to talk more about the actual structure, which is what the topic that was the genesis of me asking Sarah to come back right away, because during the Exudate show, she got into this explanation about how the root structure is different in coco coir and peat non-soil or soilless containers than it is in living soil. And I wanted to go down that path, but we just didn't have time then. And so here we are today, and we're going to go down that in a lot of different ways. So Sarah, let's start at the top. When we use the phrase root structure, what specifically do we mean?
I think, when I think of root structure, I think about the root ball itself, the different components that make up the root structure, and how that differs between plants, whether that be cultivar or species or whatever. And that's usually how the different components might be arranged, whether they're present or absent. All of that would be something I would call root structure.
So in a typical cannabis plant, what would we expect the root structure to look like in soil? Is there, since in nature it's in soil, I'll say that the soil root structure is the air quotes more natural one, just for the time being. Just okay, let me get away with that. And so what would we expect root structure to look like in soil, in the ground, outside?
Okay. We can stick with our beautiful cannabis plant. A nice big taproot goes straight down as far as it possibly can grow. You can think of that like the vertical axis, I guess. Mm-hmm. And then from that, all these lateral roots start to grow that kind of stick out from the main root, and they go sideways. So they're trying to increase the different places that the root can access. And then from there might be even more little branches and more little branches. And then at the growing tip of the root, there's a little tiny zone there where there's a bunch of little root hairs that grow. And they don't live for a hugely long time, because that root is still moving places, and so maybe a couple of weeks. But they're so tiny, we can barely see them with the naked eye, and we definitely can't see how thin they are because they're a single cell wide. But they would be just in a little, maybe, a couple centimeters long zone right there, and they would kind of bush out into the soil.
When I see diagrams of root structures of different types of plants, some of them go, quickly, really deep, and some stay at the top, and then some will throw down like a taproot, and then the rest will stay at the top. What is the architecture of the root system in an adult plant? Are they mostly up top where they can support the plant from falling over and get rainwater, or with a cannabis plant are they all making this mad dash for depth in order to create stability that way and get water that is in the soil or aquifer?
In cannabis plants, I guess we talked about this a little bit earlier. Like if it's a clone, it might not get as deep if we're talking about like in soil, because it doesn't necessarily have that deep taproot to go driving down to the bottom. But in most cases, like that taproot, it also anchors the plant as well. Because I don't know if you've ever tried to get up some of these weird little red carrot type weeds in your garden, you have to really yank on them. Like that taproot's deep and that plant is not falling over for the most part. So it does provide a lot of anchorage. But I think like what we're talking about, diagrams and things like that we find, like I think most of the time it depends on species. So for cannabis, it's mostly going to be on a taproot system that's going straight down. And then it's there for water, for anchorage, for all these different things. But then all the lateral roots provide support for whatever that purpose is. So it's kind of digging in there, but also increasing absorption. The deeper the taproot too, the more likely it is to survive things like drought because it can access that groundwater layer. Whereas we find in a lot of plants, and here I'm not talking about cannabis specifically, but a lot of plants that make surface roots, it's actually a very nutrient-rich layer of the soil where most of the organic matter sits. So a lot of the lateral roots above are meant to get nutrients specifically. They're not particularly good at getting water because there's not a lot of water usually in that layer.
So earlier you mentioned that in container plants, clearly the cannabis taproot cannot go as deeply because it's going to be stopped by the bottom of the pot. Other than a taproot that doesn't go as deeply as it may like, what other root structure changes might we find in the lateral and other root structures when they are in a container versus when they are free flowing in the ground?
I think mostly, I think I would have to say length. I haven't really dissected removed all the soil to have a look, but I would guess that because, and I guess it does depend on the type of pot too. So for example, we use cloth-sided pots, and they're meant to be sort of like self-pruning, so we don't get like running roots. And so for us, we would end up probably seeing more, and I'm speculating here, but I would expect to see more shorter lateral roots that are coming off that main taproot. And they probably wouldn't grow as much, but there's probably more branching. And by branching, I mean like lateral, and then these little roots branch off of that, and some more roots branch off of that, kind of exactly the way a tree looks on top, but below.
So what happens, what are the effects of compaction on the root structure? We talked in the first set about how in a pot bound plant, how the roots run along the sides. But I would think that as a plant is getting more and more root bound, that there are other changes that happen in the root zone to deal with that systemically.
Yeah, I mean, when we look at like root bound plants, like oftentimes there's just not that much soil, and I mean, I would expect the first thing would be just like the soil properties change, so you don't have as much water retention. There's not as many like when we talk about things like cation exchange and stuff like that, there might not be as many sites for that to happen. So that's basically the way that soil acts like a little kitchen cupboard, if you will. And there would be less kitchen cupboards available for nutrients to be retrieved from. And so most of the time when we have a super root-bound plant, it's just that there's not enough physical space and soil to support that much plant. Does that make sense?
Yeah, I follow
So it's not so much that the root architecture itself may be changing, although it might. It's more just, it just can't support that much root in that little space.
And so then the systems will start happening inefficiently, and it'll essentially just fall out of balance, and your plant will get sick in one of many ways.
Yeah, and it's usually like, I think the first thing I notice when plants are too root bound is like it's just hard to keep them fed and watered. You have to water more often. I've had a couple of plants that have actually almost pushed through the bottoms because I haven't had a chance to get to them. So they just kind of push the pot out of the way. But it can get pretty bad, and then you end up with a root ball that just can't sustain the amount of shoot growth that you have. And then the plant just ends up getting super deficient. And if we wanted to relate that to something like yield, I think your yield would be severely impacted because they just can't put that much nutrients towards the rest of the plant.
It's always a bad scene when you find the plant that you forgot to transplant and it's got all the roots that are coming out of the holes, the drainage holes. And you're like, oh, baby, I'm so sorry. I didn't see you over there. And sometimes you get lucky and it was sitting on something else. And so now it's re-rooted itself in like the pot under it or something, Yeah. Which is always interesting. But yeah, that's a bad day at the office when you find that you've neglected a plant that bad, because you're going to have to cut those roots, and that's not going to be a good day.
I've gotten pretty adept at pulling those roots out of holes, partly because of the way that I deal with my research plants. I need them to kind of do that. So there's ways to untangle them very carefully, but that does just go to show you how efficient plants are at seeking out nutrients. Like, nothing in this pot, out we go. We're going somewhere, and we don't know where it is, but it will find something somewhere to eat.
Yeah. And, that's a really good point. For folks who are home growers who are, growing 2 or 4 or 15 plants, where every plant is important because they need to yield their medicine for themselves, you'll have a lot more time to kind of, wiggle the plant back and forth and, gingerly pull them up and try to save as many of those roots versus, in a scaled commercial or, medical environment where you've got, 100 or 1,000 plants where, you're just going to pull your knife and go, cut, and pull it out and transplant it. And that's a very different kind of cultivation, but it is interesting how, the same problem has to be solved different ways depending on the variety of cultivation that you're doing.
Absolutely. Yeah. Yeah. And I think it's something to mention too, like if you have the time to try and save the roots, I think it helps. We were talking earlier about like how much root to lose and that kind of stuff, but the actively growing roots are really the ones you want to try and save. So I do my absolute best because those little runners are probably the most active as they're trying to escape my poor little pot situation.
So this next question is the one that was spun off in episode 99 and the exudates, which is kind of the seed for this episode, which is, coco and peat cultivation systems have become like really popular over the years, and I think still increasingly so. And in the beginning, folks were using coco coir and peat to supplement what we generally think of as living soil as an aeration and water retention solution. But nowadays, people are just using coco and peat, and they're not even using the living soil aspect. And then they are adding nutrition into these coco and peat pots with whatever kind of fertilizer they choose, from compost teas to amendments to bottled stuff. So there's a lot of options with these systems. And you had mentioned that root structure is going to be different in these types of pots. And I'm super curious to hear what the differences are.
I guess when we think of root structure, we kind of have to back up and realize that the root structure is kind of dictated by the environment and the needs of the plant. So, like when we talk about whether plants make a lot of lateral roots or not, like they're going to make lateral roots, but how many depends on things like nutrient availability or oxygen presence, absence, that kind of thing. So in a soil that's very mixed up, there's like when you mix a good soil, like it's going to be quote unquote homogeneous to your eyes. You're going to make sure that like the perlite's in there evenly, there's not a big clump and stuff like that. But on like a microscopic level, it's not really, there's little pockets. And so that's going to influence the plant because it has to move towards little areas of nutrients. In a system where the nutrients are actually homogeneous when we're watering it in and we're not necessarily providing any other source, the plant's still going to be moving around in there, but it might need to act differently because it doesn't have that many different pockets in the soil system. And I think hydroponics is the most extreme of that because not only can we really see the roots to look at them, but there's just one place that all of these nutrients are, and they're evenly available. So I would expect to see less branching and less root hairs and that kind of thing.
That's interesting. So one of the things we talk about on the show a lot is how in a living soil with a good fungal environment, that the fungus is, creating channels for the water to seep through and for the roots to find their ways through. And it would be my expectation that in coco and peat systems, because there is less tiny particles of soil to fill in between, that a coco and peat system will have a lot more air pockets. I don't want to dwell on the air part, but more like passages for the roots to follow. Do you find that in coco and peat systems, the roots are growing more willy-nilly because they have so many more options instead of the fewer options that you would find in a living soil system?
I guess it depends. I think the more complex the soil system is, the more complex the roots become because they're just, like I said, they have to go adventuring for all of the things that they need, and it's not all immediately readily available. I feel like with aeration, for example, or like pockets, there's probably other things, and whether you'd notice it if you just pulled the two root systems up, you might notice it if you count up all the lateral roots, or if you measure the thickness of the root, it might change. But I think it would be a lot of chemistry would change too. Does that make sense?
Yeah,
does that answer your question?
Yeah. And then I'm going to ask you a similar question, but with two different varieties. First will be, a hydroponic version where there is some kind of cistern of water and you've got nutrients there and the roots are growing down into it. And I guess this would work for an earth box too, where the roots are sitting in the nutrient water. How will the roots grow differently in that kind of environment where they really don't have to travel at all to access the nutrition?
I think they'd probably grow down more. The one thing that I've noticed the most, at least in my own research, is that the root hairs are missing because they're so fragile. And there might, if you took out a microscope and did a little cross section and did some fancy staining, you might still see the starts of a root hair or the types of cells that could form a root hair. But when you actually look at roots that are grown in hydroponics, especially because there's a current and stuff like that, it doesn't really permit those super fragile structures from showing up, at least not macroscopically. I can't see them with my eyes. Whereas other systems, they probably would be present because they're not being disturbed as much.
Do you think that impacts the thriving nature of the plant, or is it just equal and different?
I lean towards equal and different because the purpose of a root hair is to increase absorption, and that's really important when we talk about that super complex soil mixture we were just discussing, where you might need the extra absorption because that little pocket of minerals is just a little too far away for the chemistry of the main root to help, and it just needs a little finger to go in there and collect it. Whereas in a hydroponic system, you're readily changing the nutrients over, you're readily providing it with what it needs, and it doesn't necessarily, a regular root tip might be totally fine for absorbing what's there.
I follow. So the last one I want to talk about is aeroponics. And, there are certainly not very many of us cultivating cannabis who have got adult plants that are using aeroponics. However, it's incredibly common for folks to use aeroponic cloners at the beginning of a plant's life. So my question again is, when the plant is hanging, but it is suspended and it's not, actually submerged in the nutrient water, it's actually being sprayed with fine mist. How does that impact the root structure?
Like for me, I use even finer mist. I use fog, and I notice quite a big difference. Like the plant just doesn't need to go down as much, and I don't have empirical evidence that it's like particularly long or short. But for my plants in aeroponics, I find they're pretty bushy, and those root hairs are retained. That's the big thing that I noticed there, because the fog is so gentle. It's just like a little air current, and you can actually see the root hairs come out, but they also last longer because they're not getting moved around in the soil or like used up. And so they do seem to increase absorption. It kind of makes sense when you're dealing with a very gentle fog or mist, because it's not as evenly distributed as a liquid would be, because it's relying on air currents for delivery. So I think the root hairs, they tend to stay longer, and they're more important in aeroponics there. I think if you're spraying, because like the grocery store high pressure aeroponics that keeps your lettuce wet.
Yeah. Mm-hmm.
That mist might be enough to change the root hairs depending on how fragile they are and what, again, cultivar species, whatever differences you want to talk about. If it's being sprayed directly at the root, you might see less root hairs. But if it's being sprayed into the chamber to increase the humidity, you might again see more root hairs. I think that's a big noticeable difference for me.
Yeah, right on. The root structure in fog-ponic cannabis plants is really incredible. It really looks unlike anything else. And you're right, it does look like, this more compact shrubbery with all of these fine hairs. It does look like its own animal. Do you have any suggestions for folks who are starting their clones in an aerocloner, but their plan is to move them into a coco, peat, or a living soil system, because the root system that they have when they're being moved is not designed for that environment? Maybe you'll tell me it doesn't matter, but I want to address that one way or another.
I think it does. We kind of experience similar issues when we're transferring from tissue culture too, because it's a very specific environment that the root has been growing in. It's got a certain weight to it. It's got a certain water content, all these different things that can happen at the root surface that it can sense. It's going to be very different whether it's gel or air or water or whatever you are using compared to the soil. And so my suggestion would be that, most of the times we fill a pot and then we dig a little hole and we put our plant in it. My general suggestion would be, don't do that. Fill a little bit and then just kind of hold the plant up and sort of like gently fill it in that way, so it can kind of retain that structure a bit more. Mm-hmm. You still have to be careful with like large air pockets. You're going to have to gently press down, but I think that would probably preserve the structure a little better than just kind of smushing it in there.
Don't jam it in there. Let it hang of its own accord and then fill in around it.
Yeah, I think that would be the best way, I think, to preserve that very delicate sort of structure. And I don't have, again, like this is speculation, I think it should provide the root some support as you're filling it in. And I think it would cause less damage. But it's still going to experience some differences compared to what it was growing in. So you might still see some damage just because it's not as wet, or it's having to adjust the type of nutrient acquisition it's doing, like those kind of things. But hopefully that way the root architecture is preserved. And I know that's something I do with tissue culture, is I'll fill the pot 3/4 full, and then I'll just kind of try and like fill in around it so that the root's kind of supported from below before I start squishing it down.
All right. So let's talk about comparing a couple of these different substrates as far as microbial life interaction goes. So in soil, most cultivators are looking for complex microbe systems so that the plant thrives and is pest free and has a complex terpene profile. And that happens because there is this burgeoning community of life in the root zone, in the rhizosphere. However, in coco and peat and in hydroponics, we're we're pouring nutrition, and in many cases we're pouring microbes in to the root zone, but because there is not an established soil community, I kind of get the idea that they're kind of anything that we add is just passing through because there isn't a system to sustain life in those other non-soil environments. So how does this impact the experience of the roots to thrive and to bring nutrition that the added microbes and nutrition are not, I guess I'll say, residents of the substrate, but more that we're pouring it in and it's there for a little while and then they're gone, and then the roots are waiting for us as the human to add more?
Yes. So I guess I'll answer that in a couple parts. First, supplementation of microbes. It's sort of a spicy take, but I don't love the addition of that kind of stuff because, as you say, it is very transient. And most of the times that we're like, when we talk about building a living soil and we're adding like mycorrhizae or like bacterial, I think bacterial is the easiest to get started with. And because they grow so quickly and they have such a quick life cycle, it might do better. But most of that is relying on the fact that it's going to stay put. In particular, mycorrhizae, because like the mycorrhizal structure that actually provides benefit to the plant includes like hyphae, which are basically little fungal roots that need time to grow. They're very fragile. They're even this thin, maybe even thinner than a root hair. Like if you start moving them around, and this is something I don't know if you've heard of no-till, but it's one of the main reasons why people try not to till their soil, because you're actually disrupting all those little fungal roots. And I don't see that that's really going to be something that can form properly in something like hydroponics, where there's current, and in the same way that the root hairs don't form, I would not expect to see fungal hyphae form, at least not to the extent that where they're helpful. Bacteria, a little different because, again, they can still colonize kind of on the surface of the plant root, but their main job in a soil system is to help break down nutrients and some of the stuff we were talking earlier, like provide protection and stuff, and they're just going to be more limited. As far as like how that fits into, I think it's probably easier to get that started in peat, but as you say, when we're watering it through and we're not really providing for the bacterial or mycorrhizal community as well, they're not really getting set up there before you're adding something different and you're just pouring more stuff in there. Does that answer your question?
Yeah, it does. And it would make me think then that without the constant access to the resident microbes and nutrition as you described it, and instead it's just going to be there when I add it, that you might still get perfectly fine cannabis plants, but there's some percentage of thriving, or in our case with the cannabis plant specifically, yield and terpene profile that you might experience a little less in these mediums where we have to add the nutrition through a coco, peat, or hydro system, whereas in living soils, it's there. Would you agree with that assessment that those plants will be perfectly fine and people have great success with them, but there's some percentage that's more than zero that would be benefited by the living soil approach? I'm heavily biased towards living soil. I think it's like such a fantastic, like, build an ecosystem from the ground up and let your plant live in it. I think we've talked about this before, maybe on the last time I was here, where I certainly believe that there is a shift. Like, each growing method that you use does something a little bit different to your plants, and it depends when we're talking about like terpene profiles and stuff like that. There definitely is a difference when you grow in living soil versus when you grow in hydroponics, when you stress them out, when you don't. Like, we know we can influence these terpene profiles depending on what we do to the plant. So I don't know if that necessarily makes it better or worse, but when we talk about things like bacteria and adding mycorrhizae, I think you really have to ask yourself why you're adding it. Because when we're going to hydroponics and aeroponics, we're providing pretty much everything the plant needs to
put on weight as far as yield goes. Like, we're providing it nitrogen and minerals and phosphorus and, all these little things to help it out. It might not be as good at defending itself from disease or something like that might be benefited by living soil. But like, for just making flowers grow, it'll be perfectly fine. But that's why when you're adding it to a hydroponic system, I don't know that it always is doing the thing that people think it should be doing, if that makes sense.
Yeah, it does make sense. All right. So to wrap up this second set, I'd like to get you to weigh in on pot variety, plastic pots versus fabric pots. A lot of people were happy to move on from the plastic pots because, they get hot if you live somewhere hot because they're black. B, they don't breathe, if that is an advantage. C, it can get kind of swampy in there if you tend to overwater or if you don't have a good soil structure. Versus the air pots, the fabric pots and air pots, I guess, where they talk all the time about how the roots are air pruned along the side and, there can be more oxygen exchange. But I don't really know that air pruning along the side of a fabric pot or more air exchange with the pot are necessarily good things. I know they claim them to be good things, but I don't know that to be true. It does seem that the plastic pots would be more akin to actually being grown in soil, but I don't know that. So I would like to hear you compare the two.
Okay. Well, I guess for starters, I do tend to use air pots or fabric pots, but it's sort of a combination. So if we think about the whole oxygen air thing, we do actually need soil to be aerated. Most of the beneficial microbes that we're talking about today are they're requiring oxygen just like everything else is. And on the opposite hand, we have a lot of bacteria that are not healthy that grow in anaerobic or like oxygen-free areas. So when it comes to extra oxygen, I'm all for that. It sort of prevents. I mean, there's still other husbandry things that you would want to consider, but in my opinion, it helps prevent things like pythium and stuff like that from really taking root. Mm-hmm. And like air pruning and stuff like that, it changes the root structure. I'm not 100% sure if it's for the better or if the worse, but it does seem to do a pretty good job of growing like mother plants and stuff like that. I will say they are a pain to water because the water just kind of leaks out the sides. Yeah. So you still have to have like a plastic saucer underneath, and there's definitely things that I don't absolutely enjoy 100% about them. When we look at like a hard wall plastic pot, I think you do, like, they're definitely easier to water and they definitely retain, they don't dry out as quickly, I guess. So you can put water in there. It's not evaporating out the sides. So the whole root ball, it might be easier to control for water moisture if you don't water as often or something like that. And again, I think there's other husbandry issues that you'd also have to look into as far as whether that necessarily makes the growth of bad bacteria easier or not. That often has to do with the type of soil you have too. So I don't know if it's directly relatable, but I feel more comfortable in the fabric pots. And one way to get around the miserable watering situation is to use like drip emitters or something like that, where your soil is more constantly wet, which is actually, especially for living soil, better because a lot of the microbes need to be wet constantly too. So as far as living soil goes, my personal preference would be fabric pots.
Right on. Thank you. That's great analysis. I use the fabric pots as well. And there was one thing that I learned about them that really annoyed me. I still continue to use them, but I didn't like this fact figuring it out. I was talking with Josh from Dragonfly Earth Medicine about them and about how I like using fabric pots versus plastic pots so that there's, I'm using less plastic. And he had the audacity to point out that even though we're using the term fabric pots, that nearly all of them on the market are spun plastic. Mm-hmm. And I looked into it, and damn it, he's right. And so they're plastic pots, just in a different form. And so that fact pissed me off. And so I went and I intentionally purchased actual hemp pots and they degraded and fell apart in one season. And I'm like,
they do, yes.
I'm like, well, damn, the biology of it makes the spun plastic, I guess, at least necessary for the time being until we've got another material. But yeah, me thinking that air quotes fabric pots were some kind of linen was like totally wrong.
No, and I think a lot of, I think you're probably not alone, because I think a lot of us are trying to use less plastic and that kind of stuff. And I don't necessarily think that fabric pots will mean less plastic, because it's basically like wearing a polyester shirt or something like that. There's definitely some plastic in there. But as you say, many of the natural fibers tend to disintegrate very quickly. So like felt or spun or whatever, you're gonna, the more natural and less plastic you go, the more often you have to replace them, which isn't really a big deal, I guess. When you want to like transplant into a field or something, you probably, like, if they degrade in a couple of months of watering, they're probably okay. But
what I hate though is the idea of my spun plastic fabric pots that are outside. And once I learned that as they degrade over the years, they are very likely shedding microplastics into my farm's ecosystem. And that was very disappointing to me. And so I don't have a solution for it, but I think that it's important for us all to be aware of the truth of it.
Absolutely. And I think that goes to like when we're choosing things to have a preference over, like, I think when you choose a fabric pot, because you aren't necessarily saving the plastic, and I don't think in a hardwall plastic, like especially because you're putting acidic fertilizer and things like that through, you're breaking that plastic down too. So it's a trade-off more about, is it providing you the right growing environment for your method, and then make your choice based on that. Because fabric pots certainly, in my opinion anyway, support living soil better when you get them going. But I mean, a hardwall plastic is totally fine too.
Right on. Cool. All right, let's go ahead and take our second short break and be right back. You are listening to Shaping Fire, and my guest today is plant biologist Sarah Lane. Online cannabis seed distributors often seem to be all the same, but Multiverse Beans constantly works to provide you with cannabis seeds and a buying experience that you won't find elsewhere. Multiverse Beans works directly with the breeders to secure as many packs of your favorites as possible so that they have your favorite beans long after others have sold out. Some shops simply buy breeder minimums, but I get messages all the time from breeders saying some version of Multiverse asked to buy my entire run. At multiversebeans.com, you can find rare cannabis seeds from Night Owl Seeds, including the Dark Owl sublabel, Mephisto Genetics, Square One Genetics, Robin Hood Seeds, and Ethos, and so many others. Multiverse also initiates projects with breeders to secure exclusive packs that you simply won't find elsewhere. Multiverse founder Paul Lal sees himself not only as a curator of the best cannabis seeds available, but also as a collaborator with breeders, trying to bring novel crosses to the market that his customers are asking for. Multiverse Beans also creates exclusive stickers for their popular seed varieties that are available free only when you order those seeds from Multiverse. Check out their stickers like the badass recent slap for Mothman by Gnome Automatics on Instagram at Multiverse Beans. And finally, the freebies. As you'd expect, Paul sends quality freebies with every order. And when you spend at least $150, Multiverse allows you to choose your freebies from their special selections. You can get a 10% discount off regularly priced items when you use the discount code SHAPINGFIRE, all one word, at checkout. Sign up for their mailing list to be eligible for their monthly seed giveaway worth $250. So go to multiversebeans.com now for a buying experience you won't get anywhere else. One of the challenges with buying Autoflower seeds is that often you'll have as many different phenos as you will have seeds in a pack. That can be fun, sure, but so many varieties in one pack is a sign of an immature seed line that hasn't been worked enough. I prefer my Autoflowers to be worked enough that each pheno in the pack really captures the aspects that the breeder was intending. This is why I recommend Gnome Automatics to my friends and listeners who grow automatic flowering cannabis seeds. Gnome Automatic seeds are not just crossed and released. They are painstakingly sifted again and again, tested in a wide range of conditions, and taken to a level of maturity that each plant will be recognizable by its traits. traits that were hard-earned so that you can have your best growth cycle ever. Over the last 10 years, Gnome Automatics founder Dan Jimmy has become a trusted breeder, and he continues to pour his passion of breeding cannabis into every variety he releases for you to grow. Check out the Gnome Automatics Instagram at gnome_automatics to see the impressive plants folks are growing. You can score Gnome Automatic seeds in feminized or regular at your favorite seed provider listed in the vendor section of their website. Commercial cannabis farms across the country love growing Gnome Automatics because of their consistency from seed to seed, short grow times, THC percentages, and colorful bag appeal. Farms interested in bulk seeds of more than 1,000 should reach out through gnomeautomatics.com. While on the website, be sure to check out the Gnome Automatics shirts and other merch section too. If you want reliable seeds, hand-built from effort, expert selection, and experience, choose Gnome Automatics. One of the reasons why no-till cannabis growing is so valued by farmers is because the mycelium networks in the soil remain established from year to year. And we know these fungal networks are essential because they are the nutrient superhighways that extend far and wide in the substrate to feed your plants. The trouble with growing in new living soils or blended coco substrates is that it takes most of the plant's life just to create these mycelium highways. Dynamyco endomycorrhizal fungi inoculant reduces that time and gets your plant eating a wider array of nutrients faster. And it's 3 times the concentration of the other popular brand in the US at 900 propagules per gram of 2 fungal species selected specifically for cannabis cultivation. Dynamyco is the result of 30 years of research and trials at the Volcani Agriculture Research Institute in Israel. It has also been vigorously trialed by cannabis and food growers across the US. Dynamyco is now available at grow shops and on Amazon in the United States. I love using Dynamyco to both speed up the growth of the mycelium networks in the soil, but also as a biostimulant to make clone cuttings more virile. You can see side-by-sides showing the comparative growth on their Instagram at Dynamyco. If you demand reliable growing results and appreciate the importance of an active root zone in creating a thriving plant, I encourage you to check out dynamyco.com and use the store locator to find out where you can get yours. That's dynomyco.com. Shaping Fire listeners can get 10% off any size of Dynamyco on Amazon or dynamyco.com by using the discount code SHAPINGFIRE, one word, no caps. Whether you are starting with new beds or pots, or if you want to add some zing to tired soil, choose Dynamyco to maximize your plant's potential. Dynamyco endomycorrhizal inoculant. Welcome back. You are listening to Shaping Fire. I am your host, Shango Los, and my guest today is plant biologist Sarah Lane. So here we are in set 3 for the big finish. What we're going to focus on this set is the care and feeding of a good and thriving root system, because it's one thing for us to understand what root structure is and what the root system is doing, but we as cultivators, we want to make it as healthy and happy as we can. So Sarah, let's talk about how much to water. What should our considerations be across the various substrate systems we have discussed today to make sure that we're watering in a zone that is enough for the root system, but not enough to drown it?
Well, that's a good question. So I think the first and foremost things is that roots do not like to dry out. So you want to keep making sure that the soil is wet and that the root ball itself is nice and at least damp. Obviously, overwatering is a problem because the roots then can't breathe. They're kind of like drowning, if you will, and that's a problem. But it depends on the substrate of what this looks like. For example, in hydroponics, they're kind of always sitting in water, and there it's more important to make sure that the liquid is aerated properly so it's not stagnant. In aeroponics, this is almost never a problem. You just want to make sure that the spray is happening often enough that the roots are not drying out while they're waiting, because it's not usually a constant thing. And then in soils, we want to usually, when I'm watering, I lift my pot up a little bit. And as it starts to get lighter and lighter, you know that the water is evaporating. And then before it has a chance to get too dry, then you water again. And with living soil systems, it's even more important that it stays damp. So if the surface of the soil starts to dry out too much, it isn't that healthy for that system. So then I would check probably daily or every couple of days to make sure that that top layer is staying at least damp to the touch.
And that's another good reason to use some kind of a small plant cover crop of some sort to keep the top of the pot moist, so it doesn't go hydrophobic and push the water off, and helps the water get into the pot. I would think also that cover crops would be helpful because the roots of the cover crop also interact with the roots of the cannabis plant, and they communicate and share resources, right?
Absolutely. And cover crops are an excellent, especially if you're working in a soil system, they can be super beneficial. Not only to keep the water in because it's not getting lost and evaporating as much, but also, as you say, because those roots are providing like a little layer of support and networking. If you are careful about what you choose, you can also be contributing nitrogen. For example, we often plant like microclover or red clover in our pots because it does kind of give back to the system, as opposed to some cover crops where it would also be using up nutrients.
I'm forgetting the vocabulary word for it, but there are certain plants that you can plant as a companion plant that actually does the other plant harm. Are you aware of any plants where the roots of that plant actually are combative against cannabis roots?
Off the top of my head, I'm not 100% sure. I know some like classic, I think what you're referring to is allelopathy.
Yes.
And there's like definitely some plants that are just like absolute no toxic, but they're like big trees. Like you never plant anything under black walnut. It's like a circle of death. But you're obviously not planting that next to a cannabis tree. I think if you're worried about it, sticking strictly to things like clover, and some of the, like if you go to a farm supply store, they often have good cover crops there. And those plants usually are compatible with a lot of other plants. I don't know anything off the top of my head that I would want to put in a pot that would do that, but yeah.
Stick with the basics unless you're choosing to research it first, essentially.
Basically, and like there's lots of great options. We do marigold. You can do like basil. You can do like some types of herbs are pretty good in there. Basil's really good. Basil and marigold both are good too because they can be planted in with your cannabis plant, but they also act as like an insect trap because like everything loves basil. So if you plant a basil plant, you're probably getting first signs of bugs will show up there, so they can be kind of useful that way. And of course, like the clover is a really good one too.
I've gotten into the habit of throwing different types of food producing plants in my pots. I toured a farm where they were growing potatoes under their plants outside in the kind of the duff berm that they were doing out there at Green Source Gardens, and I thought that was such a great idea. But like we have to be in containers where we are. So I got strawberries grown in one. I got carrots grown in another.
Oh,
I got like culinary herbs in another, and you get that win from the cover crop, but also if you get hungry out when you're working in the field, you have snacks. So
a little snack. That's great.
Totally, right on. So how impactful is the pH of the water that we're watering with on the root system?
I think that depends on the soil. So the pH of water, that's one of the things that preferentially kicks off nutrients. And so the more acidic the water, I think the more nutrients you might kick off.
What does kick off mean?
So I guess if we want to talk about the soil as like essentially a kitchen cupboard, all these structures that you see with your naked eye on the soil have all these little charges on them that sort of collect all the nutrient salts that you're adding, whether that's because a bacteria has broken it down or not. As I said earlier, everything is basically a salt at the end of the day. Mm-hmm. But it stays there until something would prefer to be in its spot more. And that's usually acidity. So it will take its place on that soil structure. And because it takes the place, then that nutrient is free and it can go back into the water. Does that make sense?
It does.
So then once that ion or salt is free, then the plant can use it. And so the plant actually does it itself. It makes acids to go out into the soil and to kick off all the nutrients off the soil so that it can take them up. And if you are watering in like an acidic like liquid, even if it's just like water itself, or whether you've added like citric acid or something like that, you're going to be doing the same thing the plant is doing. But you can do that in excess where it would be too much. But the soil kind of buffers itself too. So it's one of those things where on a big level, I'm not sure it's that impactful, but that's what's happening on a small scale.
Mm-hmm. So as far as like what we can learn from this, it sounds like, unless your water is making a significant swing, that the buffering of the soil, and if you're generally trying to stay near neutral anyway, the watering that you're doing is not really all that impactful on the roots on the pH level, because it's the system is more or less going to self-regulate so long as there isn't something like really wild happening.
Yeah, pretty much. And I will put the caveat in there that hydroponics is a little bit different, and I've heard multiple opinions about whether to pH your hydroponic feed or not. I personally do, because it's hard to, especially over time, it's hard to tell what the soil or whatever medium you're watering into has retained. And so making sure that your nutrients are the pH they should be at before they go in sort of helps if your soil's out of whack. But that's, some people don't, and they seem to find it works fine. So again, it might just be like we were talking about earlier, all these things that we do because someone else told us to do it.
Yeah, totally.
It might not matter in the end.
Right on. Let's talk about temperature. So there's a lot of different variables that can impact the temperature of the substrate in the container. This isn't something that we need to worry about in soil because geothermal takes care of any plants that are actually in the ground. But, dark colored pots are going to attract and hold more of the sun's heat. We've got greenhouses and tents outside that can get exceptionally hot on really hot days, even if have got fans in them. And I run into this on my deck because the hours right before the sun goes down, my deck will get up to 95, 115, like way up there on a hot day, and any plants that I have on my deck will just cook. I just imagine the root zones just like turning to mush. So I'm sure that there is a range though where the temperature of the root zone is optimum. So would you kind of talk about what temperature range makes sense for the root zone? And I don't know, I guess the only way we would know on a hot day would be to actually throw a probe in there.
Yeah. So I guess the first part I would mention is soil's kind of insulating. And again, this kind of goes back to your growing method. Like if you're a bare root ball hanging in hydroponics, that's going to be way more important on a deck or something like that. Like I think the same range that you'd expect the plant to grow in. So like 30, or I guess I'm in Celsius. I think like around like a mild spring, summer day would be fine. Obviously, if you're getting up to really, really hot summer days, you're going to start seeing some effects. But the soil does buffer it. It both hangs on to heat, but also protects it a little bit. And most of the time when we're looking at, I guess the second part is when we're looking at heat stress on a plant, most of what's happening is water. So the heat is causing them to photosynthesize more. They're losing more water because that's a direct part of photosynthesis is to lose water. And because it's happening at a faster rate in heat, and they're also getting cooked at the same time, so their leaves are kind of not happy, it can put a lot of water stress on a plant. So that's why you might see wilting or burning or those kind of things. And so if it's a hot day, I think the best way to keep the insulating properties of the soil would just be to water more, because the water is going to take up some time to properly heat up. It's also going to be providing for the fact that the leaves are transpiring more, and it's going to keep the roots a little cooler.
On hot days like this, it's kind of generally accepted that it's better to water more times less water during a hot day, because you don't want to say, oh, it's a hot day, I'm going to water more, and just go with more volume, because now not only is the plant trying to take up water, but you've kind of like, flooded the substrate, and there's like almost too much water, and it has to deal with moving the water around at the same time as trying to take on water. Would you agree with that best practice, that instead of doing your same 2 waterings a day, but make them larger in volume, instead do maybe even less than you would on a normal day, but break it up into maybe 4 waterings?
I feel like there's a couple options there, because usually when I'm dealing with plants that are outside, that are like it's a heat dome or whatever, I water more in early morning when it's not hot, so that the plant can, I guess if we want to call it water balance, like then it's not already water stressed when the heat hits. Mm-hmm. And then I probably would check more, because I don't know if you, like, if it's best practices and people tend to follow that rule, far be it for me to go against that. But I do think that it's less about like the volume of water. I think especially in pots, there's only so much water that you can put in there per soil amount, but it evaporates really fast. So I would say that it's better to water more frequently, and then maybe you don't have to add as much water. But like in a pot on a patio, there's only so much water that can fit in there, and it's not going to be enough to keep it like cool throughout the whole day.
And the amount of water is probably going to also change about whether or not you're in a hard-walled plastic or if you are in a fabric pot too, because those fabric pots, they just get all hot and they start to, lose water out the sides pretty fast.
So fast, yeah. And like in a garden, for example, I think because of just how much soil there is, like if you're in soil in the ground, like a good watering first thing in the morning before it actually gets really, really hot, you might have to check on it partway through the day. Hard wall, like I was mentioning, but yeah, absolutely. For fabric pots, because they evaporate out the sides as well, they're just not going to retain as much water. So yeah, and in which case, like you're going to be watering again in 2 hours anyway. You don't need to flood the poor thing.
Yeah. Right on. Let's talk a little bit about supplements. There are different types of fungal supplements that are sold that people say to mix into your soil, so that when you transplant a pot, the roots will interact with the supplemented fungi, and will support root growth. Essentially the connection with the between the root hair and the supplement will wake up the supplement, and that fungal presence will ease the transition of the plant. Do you see that happening, and does that kind of support make sense?
I think it does to a certain extent, but it depends, like we were talking earlier, about the system that you're coming from and into. So it does take some time, if we're talking about like mycorrhizal inoculum or something like that, it does take time for that process to happen, because like I was alluding to earlier, it's a conversation between this fungus that's trying to help out and needs the plant, and the plant which has to prepare itself to accept the fungus. So it can be helpful to get that going early, but it really only makes sense, especially for fungus, I would say, if you're going to then put it into a pot where it's not going to be disturbed, or into the garden where it's not going to be disturbed. And I also think it depends on the health of the system you're planting into. Like in a pot, we have good control over compost and stuff like that, but it's a real old garden remedy to put a little extra stuff in there when you transplant into maybe not as rich of a soil or something like that, to give it a kickstart. And I would say if you're doing that with inoculum too, and you're not confident that the health of the soil you're planting into is that great, then I'm sure that would give it a little boost. And with bacteria, I think bacteria are a little bit more broad, because they don't have those like root type structures like the hyphae. They don't have that hyphae like the fungus do, so they're more likely to just kind of build up a little film somewhere, and that's probably easier to water in different systems or more systems. It might apply to more systems, but I think there's no harm in trying. Again, some systems are just not that set up to support it afterwards.
In the first set, you mentioned 2 or 3 different simple teas that you like to use. for nutrition for the root zone. I was curious whether or not you have any of those simple recipes for beneficial bacteria to improve the root growth, because you've mentioned beneficial bacteria a couple different times as playing an important role of both helping the roots thrive, but also breaking down nutrition for the entirety of the root zone. I don't know if there is such a thing. I'm just kind of fishing here, but do you have a beneficial bacteria prep that can be poured into the pot and will help out?
Yeah, I think there's a bunch of good recipes online, but what we often do, and what we do actually in research about beneficial bacteria and how it helps the root, is to take soil or compost that's already full of all the microbes you need, and then put it into some very well aerated water, and then you can add a sugar source of some kind, depending. I know people talk a lot, and this is also very, I guess, veers into sort of compost literature, but you can get like green compost and brown compost, and those will have different types of microbial communities in them. And so you can be pretty confident that if you're taking a sample from a healthy soil and providing it food, like a sugar source, that you're going to get a lot of beneficial organisms, including beneficial bacteria. So that's usually what we do. We like a good couple of composts, a little bit of molasses, like I was saying earlier, and then something for it to nibble on, like leaves, or like I was talking about earlier, bracken fern and stuff like that. And depending on the ratio, you're going to get different stuff.
Now, are you talking about a brewed compost tea in that point? Because the delineation I'm trying to make is, adding molasses to a compost brewer, if you're going to let it run for 36 hours or something, and so you're going to incubate those microbes, or in this case bacteria, that we want, and then root drench that into the pot. That's one use of molasses. But then I also have been hearing folks talk about, I want to feed my microbes, and so they're pouring molasses or a water molasses slurry into the pot directly, which that sounds super scary and unbalancing to me, versus in the first example, we're going to add enough molasses that's going to feed the microbe and bacteria communities, and then we're going to pour it in the pot, which is going to decrease the, hotness, if you will, of the molasses.
Yeah, I guess like I just assumed we were talking about culture, which is my bad. I should have clarified. When I use compost tea, my idea is usually based off of, and I know a lot of people do this too, that you're taking a small amount of something and trying to encourage growth of that something into a supplement. You can just water in compost water and it will do just fine, and it might take a little longer. But remembering that a lot of these bacteria and fungus, like, they eat the stuff that's already in your soil. So like, rather than add molasses, you could probably add leaf litter or compost or something like that to help them, because that's what they're eating at the end of the day. So when I'm talking about molasses and aerated teas, I'm definitely talking about a brewing tea where you're trying to grow microbes for watering in later.
Great. I just wanted to make that delineation really sharp, since we talk about both aerated compost teas and then compost extracts, right, which won't be aerated. And I don't want anybody to get those confused and just freebase molasses into their pot, because
Totally
because it happens, unfortunately. And then they get a decent plant, and then now they swear by it, right? And it's like, but that's dangerous. So right.
Yeah, and like superstition, you have the things that make you work, and like if it worked for you, you're much less likely to not do exactly what you just did because it did already work for you. And there isn't really any harm in watering compost in, because it's already got all these nutrients. If anything, you're just freeing up the loose nutrients that were already free in the compost and watering them through your soil column, and then you also have all those little microbes that come with. So if you don't have an aerated compost set up for brewing compost teas, you can certainly just take a couple of handfuls of compost, put it on top, and water through, and it'll do the same thing. It might just take a little longer because you haven't encouraged the growth of those microbes in the same way. I don't know about the sugar. I tend to agree with it might get things a little toasty in there.
Yeah, right on. So before I go to the last question of our chat, I want to just throw a wide net here. Is there anything else that we haven't talked about today that can be done to support healthy root life and root growth? I just want to mop up any other best practices that I may not have known to ask you, but because you are Rootly, you might know. So is there anything else that you would suggest or recommend?
I think we've kind of covered a lot of areas that I would talk about with root health, but I think one big one is like trying to avoid disturbing the root system and really going for some sort of balance, because I feel like we often just kind of manhandle them. They're this mysterious thing under there that we don't really think about. And if you're going to go for a healthy plant, you need both a healthy top half and bottom half. So being gentle with them, trying to think about the different things that you can do to support them, especially the watering part. We don't want stressed out roots, so making sure that you're keeping them wet and able to do their job. I think that's a big one. But I think all the things we've talked about today are good ways to try and promote root health. But at the end of the day, it's up to the plant, and you can usually tell if the top half is healthy. The bottom half is probably pretty good too.
Right on. It does seem like, we keep on coming back to the thing that our cannabis plants like the most is balance and consistency, right? Mm-hmm. If you can go slow and steady, do the same thing every day and try to keep it a consistent environment, while that is so hard, based on our different bioregions, it is the name of the game.
Absolutely. And especially, I guess the other thing I would mention is we focus very much, especially on a plant like cannabis, where we have an end yield that we're really interested in, that you still have to respect the process of growing it and making sure that the whole plant is healthy. Because at the end of the day, that one little part of the plant you're concerned about relies on all of the rest of the plant to grow properly and in the way that we want. So don't neglect your roots.
Yeah, amen. Right on. All right. So for this last question, it's fun. It is still a root question, but it's coming from a totally different direction. So, all the way back, like, I don't know, 4 or 5 years ago or so, on Shaping Fire episode 26, I interviewed your neighbor up there in BC, Natasha Riz. Are you familiar with Natasha?
I am.
Oh,
We've
fantastic.
had quite a few nice dinners together.
Excellent. Well, we like her too. And we had her on the show to talk about root ball medicine, because the cannabis roots are filled with all sorts of cannabis biochemicals, I'll say, that do things like reduce inflammation and other things that we tend to use the tops of the cannabis plant for. And there are these biochemicals, like there's triterpenes in there. And the one that most people focus on is Fridolin, Frieddelin, for anybody who that's new. But then there's also a whole bunch of other ones, which I could totally butcher the names of. But the point I want to get to is that, since that show, I have had audience folks from across the country reach out to me and say, hey, we've started making these tinctures and salves from the cannabis root zone, and we're getting really good effects from them. But we want to know how to grow roots that have got more of these various sterols and alkaloids and triterpenes and these useful, delicious, medicinal biochemicals. And they ask me, what can I do for the plant so that my roots are more rich with these target biologicals? And, I don't have an answer for that except to say, a thriving plant will probably produce more of those, like it does more resin and more terpenes. But I don't know, I just made that up. I just given my best educated guess. Right. But this is so similar to the kind of research that you're doing. I'm wondering if you have a more educated guess.
I actually love this question. I think that my work at UVic is very focused on trying to use plants, like plant processes that the plant already performs, to try and find things that are medicinal about it. And this kind of does exactly that. So when we think of the different types of molecules that we find medicinal in a plant, they often have some sort of what we call broadly bioactivity, which just means that it has some sort of job that it can do in a biological system. And like a common example of that might be like an antibiotic. Like if we take it, we get rid of an infection, hooray. And it's usually from something that is also trying to fight off an infection. So a lot of our antibiotics might be derived from a bacteria that was trying to fight off another bacteria. We found out it worked, so we use it. Same with antifungals and things like that. So my work is mostly trying to decide, okay, if this is something that plants already make these molecules for, what if we stress them out a little bit in this way? So for example, if you wanted an antibiotic, then you maybe give it a little bit of an infection or something like that, because then it might make more of that antibiotic for you. I don't know how this translates to root medicine necessarily, because a lot of these things we don't fully understand what they do. Like we know that when we take them, they have a lot of medicinal aspects, and especially with cannabinoids, they have so many different things that they do for us that they've been all sorts of different things that we have found out about them. But a lot of those aren't things that plants do, right? Like they don't, like for anti-seizure, for example, like plants don't have seizures, so we can't make them have a seizure to make more of that. But for some of these things, like that molecule you were just talking about, if it has an antifungal activity or something like that, then maybe a plant that has a fungal problem might be good. And then the other thing would be, we don't want plants that are too stressed out, though, because it still needs to have energy to fight off whatever you're giving it. So it might be something where you can just expose it to any bacteria, like maybe a compost tea, and maybe it has some friends and maybe some not so friendly bacteria in the compost tea, and maybe that will stimulate it to make a little something extra. And I'm just going to put the caveat that I'm not telling you to go out and like try and make your plant super sick or anything.
Dump fusarium in them or something, right?
Yeah, please don't do that. But there's ways that we can, same with our own bodies, like being exposed to outside and those kind of things, or eating organic foods that have things on them and those kind of things. Like we know that that if we're too sterile, our systems aren't happy. So maybe the suggestion would be to just feed them some compost teas and some of the stuff that we've been talking about today, so that the roots are not only healthy but also are interacting with other organisms, and then maybe that will stimulate more of a response. Just a guess.
Yeah, I like that guess. And while you were saying that, I thought maybe we could get that from watering in some non-local indigenous microorganisms, right? I mean, we talk about IMOs all the time and how much we love them, and how helpful it is to use localized ones. Well, maybe if we were to use some IMO from a different environment, since that will have a whole bunch of strangers to this environment, maybe you can get a similar defensive medicinal capability without having to go so far as to, actually cause damage to the root zone. Just threaten it.
Yeah, and like this might even be like we know that microbial communities are pretty local, and like even maybe local to your garden versus like across the street down the hall. So maybe it's just as simple as like if you live next to a bunch of oak trees and your friend lives next to a bunch of pine trees, maybe you just get some soil from there and water it in.
Right on. Cool. Well, thanks for going down that theoretical line with me, just because, you're my root expert. And I know I'm going to be getting this question more. And so at least I've got, more to say, even though we don't know exactly what it is. So thanks for that.
No problem.
And thank you, Sarah, for joining us again. I'm so glad that we got a chance to continue the conversation that we started in episode 99 about roots, because there really is so much there. And that really showed me how much I take the roots themselves for granted. I talk a lot about the rhizosphere and the root zone and the community and all that, but specifically the roots, I just kind of take them for granted. And the more questions I asked last time we talked, the more I realized I didn't know. So thank you so much for joining us and sharing your, good cheer and expertise and helping us grok a little more about what's going on underneath the surface in our pots.
Oh, my pleasure. Thank you so much for having me again.
Right on, dear listener. So if you are interested in reaching out to Sarah Lane or just to kind of follow her along, she doesn't do a lot of social media because she's focused most of her time on the research, but there's one place that you can follow along, and that's at her Twitter. And her Twitter is Exudet Rootly. So that is EXUDETTEROOTLY. And if you have a question that you have not been able to find the answer for out there on the internet, or an answer that you actually believe, Sarah does invite you to write to her directly, but make sure that you give her some time to get back to you, because remember, she is in a doctorate program right now, and her email is slane, so that's SLANE, at uvic.ca. So that's UVIC.ca. You can find more episodes of the Shaping Fire podcast and subscribe to the show at shapingfire.com and wherever you get your podcasts. If you enjoyed the show, we'd really appreciate it if you would leave a positive review of the podcast wherever you download. Your review will help others find the show so they can enjoy it too. On the Shaping Fire website, you can also subscribe to the newsletter for insights into the latest cannabis news, exclusive videos, and giveaways. On the Shaping Fire website, you will also find transcripts of today's podcast as well. Be sure to follow on Instagram for all original content not found on the podcast. That's at Shaping Fire and at Shango Los on Instagram. Be sure to check out the Shaping Fire YouTube channel for exclusive interviews, farm tours, and cannabis lectures. Does your company want to reach our national audience of cannabis enthusiasts? Email hotspot@shapingfire.com to find out how. Thanks for listening to Shaping Fire. I've been your host, Shango Los.